Good afternoon, everyone. Welcome back to class. Today I will give you a short lecture about kinetic energy. Before you leave this afternoon, you will understand what is kinetic energy, how can we measure kinetic energy, and how can we calculate kinetic energy. Before I start my lecture, I'd like to ask you a question. Why it hurts more when a person is hit by a moving car than by a moving bicycle? At the end of this lecture, you will answer this question easily. Before I introduce the definition of kinetic energy, I'd like to explain the meaning of kinetic. Kinetic is a word coming from a Greek word kinesis, which means motion. So kinetic energy has something to do with movement. So kinetic energy is defined as a kind of energy which has something to do with motion. As long as an object is moving, it has kinetic energy. In contrast, if the object is at rest, it has no kinetic energy. So, for example, a moving car on the street, it has kinetic energy because it is moving. But the desks in this classroom have no kinetic energy because they are at rest, right? So, by now, I have giving the definition of kinetic energy, which is a kind of energy that has something to do with motion. So let me introduce how to measure kinetic energy. Kinetic energy is not a kind of concrete object. We can't see it, we can't touch it. So how can we measure it? So here comes the unit of kinetic energy. The unit of kinetic energy is joule, which comes from the name of this famous physicist, Joule. Okay, let us try to interpret the unit of kinetic energy. I will give you some examples. So, what does 1 joule mean? If you give a force with 1 Newton to an object and move that object for a distance of 1 meter, the work done by you is just 1 joule. Does this make sense? Not really, right? So I will give you some numbers to help you understand. So an ordinary moving car has a kinetic energy of about 300,000 joules. That is a lot of energy. But the kinetic energy of a moving bicycle is just about 1,500 joules, which is much less than the kinetic energy of a moving car. So till now, I have covered the definition of kinetic energy, which is a kind of energy that has something to do with motion, and I have also introduced the unit of kinetic energy, which is joule, and we often use the big J to represent joule. Now, let me move on to the calculation of kinetic energy. Now we'll do something about the formula. So this is the formula we use to calculate kinetic energy. It's Ke equals to 1 over 1/2 mv squared. What do these symbols mean? So Ke is kinetic energy, m is a mass that is the mass of an object that we are interested in, and the velocity, v is the velocity of the object. So let me interpret this formula. So kinetic energy equals to 1/2 times the mass of the object and times the velocity square of the object. How can we use the formula to calculate kinetic energy? I will give you 2 examples. First, a moving car whose mass is 1,500 kilograms and with a velocity of about 20 meters per second. How much is its kinetic energy? So, what do we know about this question? So we know the mass and we also know the velocity. So we just plug these numbers into this formula. Ke equals to 1/2 mv squared. And we do some algebra and we can obtain the kinetic energy of a moving car is about 300,000 joules. That is a lot of energy, right? So now, here is another example. It's a moving bicycle whose mass is about 120 kilograms and the velocity is about 5 meters per second. So what is the kinetic energy of this bicycle? So we just do the same thing and we obtain the kinetic energy is about 1,500 joules, which is much less than the kinetic energy of the moving car. So let's go back to the first question I asked you at the beginning of this lecture. Why it hurts more when a person is hit by a car than by a bicycle? So from these 2 examples, you know that the kinetic energy of a moving car is much greater than the kinetic energy of the bicycle. So when a person is hit by a car, the car will release a great amount of energy, which will hurt the people very much. So that is the reason. So that is what I want to say in this class. Let me give you a brief summary. The definition of kinetic energy is that kinetic energy is a kind of energy that has something to do with motion, and the unit of kinetic energy is joules, and we often use the big J to represent joules. And we have a very simple formula to calculate the kinetic energy, which is just 1/2 mv squared. So that's all. Do you have any question?
Yeah, Professor, I do have a question, which make me very confused. So we talk about the kinetic energy in this lecture, but I'm wondering whether there are any other kinds of energy. I mean, there must be, right? Because, yeah, I think there must be other kinds of energy. Can you name me some for me? Thank you.
Okay, that's a good question. There are, of course, there are some other kinds of energy. So, for example, we have if you go outside of this classroom and sit in the sunshine, you will feel warm. So that is because of the energy of the sun. We call it solar energy. And also, I'm sure you are familiar with the story of our famous physicist Newton. One day he was sitting under an apple tree, and an apple fell and hit his head. So that is because another kind of energy, which is gravitational energy, which made the apple fall and hit him. So yeah, so I just give you 2 examples.
Okay, thank you. Professor, I have another question. I used to serve in the U.S. Army, and I was hit by a bullet, and which hurt me a lot. I was in the hospital for 3 months, and I'm very confused about. How can such a small bullet can cause so much damage? I think there must be some relationship between this and the topic we covered in this lecture. Can you answer this question?
Oh, that's a really good question. So let's go back to the formula. So this KE equals to 1/2 times mv squared. So kinetic energy is related to both mass and velocity. Even though the bullet has a very small mass, but the velocity of the bullet is very great. So if we do the calculation, so we will find the kinetic energy of the bullet is very large. So it can cause some damage. Yeah. So does this make sense?
Yeah, absolutely. Thank you.
Thank you.